Try lifting your head and gazing at the night sky, where thousands of stars glitter across the heavens like an endless silk tapestry. Every point of light you see is a star, possibly tens, hundreds, or even thousands of light years away. But have you ever wondered which stars are actually closest to Earth? Beyond our blazing sun, do we have cosmic neighbors quietly existing around us, so faint they escape the naked eye, yet holding within them enormous secrets of the universe? What's fascinating is that we live in a far busier stellar neighborhood than you might expect. Within just 16 light years of the sun, about 151 trillion kilometers, there are more than 50 star systems. That number might sound small, but compared to the vast expanse of the Milky Way, it's like realizing that right around your house lies a whole community of characters. Noisy, fiery neighbors, gentle ones who mind their own business for billions of years, and everything in between. Most of these stars are red dwarfs, tiny and dim, invisible without powerful telescopes. But don't let their faintness fool you. Around many of them orbit planets, some rocky and Earth-like, some even sitting in the habitable zone where liquid water could exist. And where there's water, the possibility of life, even primitive life, suddenly doesn't seem so far-fetched. It's astonishing to think that these neighbors have been by our side for billions of years, yet only recently has modern science begun to uncover their identities. To our eyes, the night sky looks calm and serene, but in truth, it's more like a bustling cosmic city. Stars weaving through their orbits, planets silently circling their hosts, bursts of energy sometimes tearing apart the atmospheres of unlucky worlds. Here's a curious paradox. The stars nearest to Earth are often not the brightest ones we see. Sirius, the dazzling star that dominates our sky, isn't among the closest, while Proxima Centauri, the nearest star beyond the Sun, is completely invisible to human eyes. It glows faintly, like a dying ember lost in the cosmic ocean, yet it has become one of the most important scientific targets in the search for Earth-like planets. This contrast is part of what makes the universe so captivating, turning every discovery into a page from a mysterious storybook. Now, imagine if we could launch a spacecraft that traveled thousands of times faster than anything humanity has built. In just a few light years, barely a short hop by cosmic standards, we'd find ourselves in entirely different worlds. Some planets might be frozen wastelands where light itself is swallowed by the dark. Others could be scorched, their surfaces melted from orbiting too close to their star. And somewhere out there, perhaps, are blue-green worlds where rivers flow and seas ripple under the gentle glow of a red sun. Neighbors, in this sense, doesn't mean houses on a street. It means whole star systems, each with its own collection of planets, moons, and asteroids. What makes this journey even more compelling is the question at its heart. Are we alone? If just within a few dozen light years there are dozens of stars and hundreds of planets, what happens when we look out thousands of light years? Could there be another planet quietly circling a faint star, with its own forms of life staring up at their sky and wondering about us, just as we wonder about them? Today's journey will take us from the most familiar place of all, the sun that gives us life, outward to the faint but intriguing stars within 16 light years. We'll begin with the only star humanity has ever visited with spacecraft, then venture farther to Proxima Centauri, the nearest yet elusive neighbor, to Alpha Centauri, the shining pair tied to science fiction dreams, to Barnard's star, the sprinter of the sky, to Wolf 359, a quiet ghost of a star, to Sirius, the brilliant beacon steeped in culture, to Ross 128, the gentle but promising neighbor, and finally to Gliese 581, the star that once electrified the world with whispers of a second Earth. Each stop adds another piece to the rich mosaic of our cosmic neighborhood. Think of this as a guided tour of space. Instead of crowded streets, we'll be crossing vast, silent voids. Distances of just a few light years would take today's spacecraft tens of thousands of years to traverse. Yet with imagination and knowledge, we can leap between them in an instant. Through science, curiosity, and a touch of wonder, we'll knock on the doors of nearby stars, listen to their stories, and ask if behind their faint glow might lie living, breathing worlds. So let's begin. Starting from the sun, the birthplace of all life we know, we'll step beyond the borders of the solar system and set out to meet humanity's closest neighbors in the cosmos. And who knows? Along the way, we may find not just new knowledge, but also a deeper understanding of our own small yet meaningful place in this vast universe. If the universe were a vast city, then the sun would be our home, the place where life as we know it resides. It's not only the source of light and energy that sustains every living thing on Earth, but also our first landmark, the reference point we use to understand all the other stars scattered across the cosmos. Before we leave behind this blazing torch and step into the darkness of interstellar space, we need to pause for a moment to look closer and to understand why the sun is at the very heart of our journey of discovery. On average, the sun sits about 150 million kilometers from Earth, a distance astronomers call 1 astronomical unit, or AU. Whenever we describe how far away another planet or star is, the Earth-Sun distance serves as our ruler. Sunlight itself takes about 8 minutes and 20 seconds to reach us, which means that every time we glance at the bright sky during the day, what we're seeing is actually the sun from 8 minutes ago. If something catastrophic were to happen to the sun this very instant, Earth would remain blissfully unaware, basking in its calm glow for just a few minutes longer before the storm arrived. Peering inside, the sun reveals a layered structure, like an enormous cosmic onion. At its heart lies the core, where nuclear fusion takes place. Here, extreme pressures and temperatures, reaching over 15 million degrees Celsius, force hydrogen nuclei to collide and fuse into helium. This process releases staggering amounts of energy in the form of radiation and particles, the very fuel that powers the sun's brilliance. If the sun were a power plant, the core would be its nuclear reactor, running steadily for 4.6 billion years. From the core, energy takes hundreds of thousands, even millions, of years to escape through the radiation zone, where photons are trapped, bouncing endlessly like light caught in a cosmic maze. Eventually, it reaches the convection zone, where giant currents of plasma churn like boiling water in a pot. These movements give the sun's surface its restless appearance, bright and dark granules, swirling patterns of energy that we can capture through telescopes. Beyond the interior lies the photosphere, the face of the sun, the layer of light visible to our eyes. Here we see sunspots, cooler, darker regions caused by magnetic disturbances. Above that is the chromosphere, a thin reddish layer that becomes dramatically visible during a total solar eclipse. And stretching out millions of kilometers farther is the corona, a ghostly halo surrounding the sun. Normally serene, the corona sometimes erupts violently, unleashing streams of solar wind and massive coronal mass ejections that sweep across interplanetary space. These phenomena may sound distant, but they affect us directly. The solar wind, streams of charged particles traveling at immense speeds, collides with Earth's magnetic field, creating shimmering auroras at the poles. But when the solar wind grows too strong, it can spark geomagnetic storms, disrupting satellites, threatening power grids, and endangering astronauts. A powerful solar eruption can release the energy of billions of nuclear bombs, and if aimed at Earth, it could pose a serious challenge to our technological civilization. To better understand the sun and its tempests, humanity has launched daring missions. In 2018, NASA's Parker Solar Probe became the first spacecraft to dive deep into the sun's neighborhood, flying closer to its surface than any object before. Its heat shield, capable of withstanding more than 1,300 degrees Celsius, allowed it to capture priceless data about solar winds and magnetic fields. Earlier missions like SOHO and the Solar Dynamics Observatory gave us detailed, high-resolution images of sunspots and flares. And in 2020, Solar Orbiter began offering close-up views of the sun's mysterious poles. Thanks to these missions, we now have more accurate models of how the sun works and how it shapes the solar system. This knowledge helps protect satellites, power grids, and communications, while also preparing us for the day when humans journey farther from Earth, settling on new worlds, still under the shadow of our star's wrath. Yet the sun is more than just another star among billions. It's our benchmark, the standard against which we measure others. Astronomers often describe distant stars as sun-like or unlike the sun because it defines what it means to be a stable yellow star with a planetary system capable of supporting life. Without it, we would struggle to imagine how the universe functions at all. The sun has burned bright for 4.6 billion years and will likely shine for another 5 billion before exhausting its fuel, swelling into a red giant, and eventually collapsing into a small white dwarf. By then, Earth will no longer be what it is today. But for now, the sun remains our lighthouse, our eternal flame, guiding humanity's quest to understand the cosmos. And so, after pausing to marvel at and learn from our mother star, it's time to look outward again. Because just beyond the sun's protective glow lies our closest stellar neighbor, a name that has long stirred both science and imagination, Proxima Centauri. And its story is entirely different. After leaving behind the warm, familiar glow of our sun, our journey drifts into the endless black of interstellar space. And at a distance of 4.24 light years, more than 40 trillion kilometers, we meet our closest stellar neighbor, a name etched into every astronomy chart, Proxima Centauri. It sounds nearby, but the truth is humbling. Even if a modern spacecraft, the fastest humanity has ever built, were to depart Earth today, it would still take more than 70,000 years to reach it. That's why, despite being the nearest star, Proxima Centauri remains a distant enigma, a door barely cracked open for our imagination and ambition to peer through. Proxima Centauri is a red dwarf, the most common type of star in the universe, yet one of the least familiar to us. They are small, dim, and so faint that even the closest one remains invisible to the naked eye. If the sun is like a blazing torch, Proxima is little more than a candle flickering in the dark. Its mass is just 1/8 that of the sun, its surface much cooler, and the light it gives off glows a soft, subdued red, easily drowned out in the night sky. But don't mistake its modest appearance for weakness. Beneath that quiet glow lies a fiery temperament. Far from being calm, Proxima Centauri belongs to a class of stars known as flare stars, prone to violent outbursts that unleash colossal blasts of energy in mere seconds. A single flare can make the star shine hundreds of times brighter for a few fleeting minutes, stripping away the atmosphere of any planet that strays too close. It is, in many ways, like a sleeping volcano, silent and unassuming on the surface, but always capable of an eruption that reshapes everything around it. What makes Proxima truly fascinating, though, are the planets circling it. In 2016, astronomers announced the discovery of Proxima b, a rocky world just slightly larger than Earth, orbiting within the star's habitable zone. This is the region where temperatures could allow liquid water to exist, the essential ingredient for life as we know it. The news electrified the scientific community and beyond, because for the first time, we found a planet so close to home that might share some of Earth's key conditions. People began to dream of a second Earth, only a few light years away. But dreams rarely come without challenges. Proxima b, while sitting at the right distance, is constantly battered by its parent star's violent flares, bombarded with ultraviolet light and X-rays. If Earth endured such storms every week, our oceans might evaporate, our atmosphere could be blown away, and life would struggle to survive. Some scientists suspect Proxima b lost all its water billions of years ago, leaving behind a barren, lifeless desert. Others, more hopeful, suggest that if the planet has a strong magnetic field, it could shield its atmosphere just as Earth does, perhaps protecting deep oceans or underground environments where life might still endure. And Proxima b is not alone. Observations suggest the presence of Proxima c, a planet several times more massive than Earth, possibly a mini-Neptune, and Proxima d, a smaller candidate whose existence is still uncertain. Together, they transform Proxima Centauri from a faint, overlooked star into a potential planetary system brimming with intrigue. They remind us that even the smallest, most turbulent stars can host entire families of worlds, some of which might be hospitable to life. Yet one barrier looms above all others: distance. 4.25 light years may sound trivial compared to the Milky Way's 100,000 light-year span, but with today's technology, it's a gulf too vast to cross. Voyager 1, humanity's most distant spacecraft, has been traveling for nearly 50 years and has only just stepped beyond the edge of our solar system. It would still need tens of thousands of years to reach Proxima. The gap is like dreaming of walking to a city on another continent, knowing your feet could never carry you there, but dreaming anyway. That hasn't stopped humanity from imagining bold solutions. One of the most ambitious is the Breakthrough Starshot project, a plan to launch thousands of ultralight probes, each no larger than a computer chip, equipped with delicate light sails. Instead of rockets, they would be driven forward by a massive Earth-based laser array, reaching up to 20% the speed of light. If it works, these probes could reach Proxima Centauri in just 20 years. Imagine that. In our own lifetime, humanity could send its first letter to a nearby star, ushering in the dawn of interstellar exploration. It's still just a vision, but it captures something essential: our relentless desire to push beyond boundaries and touch the stars. The story of Proxima Centauri is a cosmic paradox. It is near, yet impossibly far, faint, yet ferocious, full of promise, yet steeped in peril. It sparks hope of other worlds while reminding us of the monumental obstacles that stand between us and life beyond Earth. Above all, it teaches us that closest in the universe still means a distance so staggering that even imagination strains to grasp it. And Proxima is not alone. It is but one part of a triple star family, a system that has captivated human curiosity for centuries. Alongside it shine Alpha Centauri A and Alpha Centauri B, larger, brighter stars with their own captivating stories. If Proxima is the small, unruly neighbor, then the pair are like two powerful siblings, symbols not only of science, but of humanity's imagination itself. And now, our journey continues as we leave Proxima behind and turn toward them. After leaving behind Proxima Centauri, the small, temperamental red dwarf, our journey drifts toward a brighter, more familiar pair of stars, ones that carry with them a greater sense of hope in the search for distant worlds. These are Alpha Centauri A and Alpha Centauri B, two stellar companions locked together in an orbital dance that lasts decades. And with Proxima, they form the most famous triple star family in the sky. If Proxima is like a cranky little neighbor, Alpha Centauri A and B are more like the older, steadier siblings you can actually rely on. Among them, Alpha Centauri A is the closest match to our own sun. It's a brilliant yellow star, about 10% more massive than the sun and nearly 1.5 times brighter. From Earth's southern skies, its light has long stood out as a guiding beacon, a celestial landmark for human eyes across thousands of years. Alpha Centauri B, by contrast, is slightly smaller and cooler, glowing with a soft orange hue. Though less massive, it too is steady and enduring. Together, the two stars are bound in a slow, graceful waltz. Every 80 years, they complete a circuit around each other, drawing closer and then drifting apart again, inseparable companions in a timeless rhythm. From our perspective, their light blends into a single point in the night sky, but in reality, it is the shared brilliance of two distinct stars weaving a cosmic story side by side. One of the great questions astronomers wrestle with is whether planets orbit these stars. Subtle hints, tiny wobbles in the data, suggest the possibility of worlds circling Alpha Centauri B. Some even suspect a super-Earth nestled in its habitable zone. Yet the evidence is still uncertain. Detecting exoplanets in a binary system as complex as this is no easy task. The tug of gravity between the stars complicates the usual methods of detection. Still, the challenge only sharpens the fascination, making Alpha Centauri one of the most coveted targets for the next generation of telescopes. The discovery of just one Earth-like planet here would be enough to shake the world. Because of its closeness and promise, Alpha Centauri has become more than a subject of astronomy. It's an endless source of inspiration for human imagination. For centuries, poets and storytellers have looked up and spun tales about the mysterious double star. In modern times, Alpha Centauri has slipped seamlessly into science fiction as a symbol of hope and migration. James Cameron's Avatar imagined the lush world of Pandora orbiting Alpha Centauri A, while games like Mass Effect place it as humanity's first stop in the dream of interstellar travel. Alpha Centauri is the bridge between science and imagination, close enough to picture, far enough to remain a challenge. What makes Alpha Centauri truly special isn't just its physical nature, but its symbolic role. It feels like the first doorway beyond our solar system, the place where humanity might one day imagine building its first colonies. Whenever people talk about leaving Earth behind and seeking a second home, Alpha Centauri nearly always comes up first. It's nearer than any star system, but Proxima, yet brighter, more stable, and infinitely more enticing. In reality, reaching Alpha Centauri would demand technology far beyond anything we currently possess. Even bold projects like Breakthrough Starshot, which aims to send tiny, ultralight nanocraft flying at 20% the speed of light toward Proxima, cannot ignore Alpha Centauri A and B. If those craft are ever launched, they won't just be sending a greeting to Proxima, but might also capture the first images of the twin suns and whatever planets may orbit them. Just imagining such a moment, a snapshot from billions of kilometers away showing another sun and its worlds, is enough to give any lover of the cosmos chills. In human eyes, Alpha Centauri embodies both scientific truth and romantic dream. It is the perfect binary, balanced between two radiant companions who have shared their orbit for billions of years. It is also a symbol of human imagination, a destination always present in our dreams of leaving Earth behind. That is why Alpha Centauri A and B occupy such a special place in our mental map of the universe. Not too distant to despair, not too close to diminish the wonder. But if Alpha Centauri is the emblem of balance, stability, and hopeful dreams, the next star on our path is entirely different. It is not as bright as A, not as steady as B, and it holds little place in the stories of popular culture. Instead, it is defined by one remarkable trait: speed. This is the star racing through the sky, the one astronomers call by a simple yet striking name: Barnard's star, the fastest moving star ever observed. And that is where our journey will head next. After leaving behind the dazzling, almost romantic glow of Alpha Centauri A and B, our journey continues. This time, we arrive at a star that lacks the literary charm or science fiction fame of Alpha Centauri, but it has something else that makes it stand out in our cosmic neighborhood: speed. This is Barnard's star, often nicknamed by astronomers as the sprinter of the sky. Barnard's star sits about 5.96 light-years from Earth, a little farther than Proxima Centauri, yet still among our closest stellar neighbors. At first glance, it's utterly unremarkable. Its dim light, only 0.04 times that of the sun, makes it invisible to the naked eye, drowned in the ocean of stars. You'd need a powerful telescope to even notice it. But Barnard's star's claim to fame isn't its brightness, it's its motion. While most stars appear fixed in place, Barnard's star refuses to stay still. Astronomers call this proper motion, the rate at which a star shifts against the background of more distant stars. And Barnard's star holds the record for the fastest proper motion ever measured. Each year, it creeps about 10.3 arcseconds across the sky, a staggering pace on astronomical scales, enough for its position to noticeably change in just a few decades of observation. That restless dash has made it one of astronomy's favorite targets for centuries. Yet Barnard's star is more than just quick, it's ancient. Its age is estimated between 7 and 12 billion years, meaning it predates the current form of the Milky Way and almost certainly existed before Earth itself. Young stars like our Sun may nurture life, but old stars like Barnard's act as silent witnesses to cosmic history, quietly watching worlds form and fade across eons. It has seen the galaxy spin countless times, generations of stars ignite and collapse, and still it endures, like an old traveler steadfastly racing along the endless track of space. And Barnard's star isn't entirely alone. In 2018, scientists announced evidence of a planet orbiting it, named Barnard's star B. With a mass about 3 times that of Earth, it falls into the category of super-Earths. At first, this discovery stirred excitement, but reality set in quickly. Barnard's star B is far too cold to host life as we know it. Despite orbiting its star every 233 days, Barnard's faint glow leaves the planet frozen, with average surface temperatures near 970 degrees Celsius. A frozen world, perhaps a desert of ice or an ocean sealed beneath a thick crust. Still, its discovery was a milestone. It proved that even stars billions of years old can harbor planets, and that the search for other worlds isn't confined to young, radiant suns. Some astronomers even suspect there may be more planets lurking in the system, though none have been confirmed yet. Imagination fills in the blanks. Icy, silent worlds circling a weary star, maybe even home to exotic forms of life clinging to survival in brutal conditions. Barnard's star also has a compelling future. In about 10,000 years, a blink of cosmic time, it will pass closer to Earth than even Proxima Centauri, swooping in to just 3.8 light years away. When that day comes, if humanity is still around and has mastered faster space travel, Barnard's star could become the first destination for true interstellar exploration. Just the thought of it sparks wonder, a gateway to another world within reach. For now, though, Barnard's star remains only a faint dot in our telescopes, a curious figure in our stellar neighborhood. It lacks the brilliance to dazzle casual stargazers, but it carries a story all its own, a fast, enduring elder star, drawing ever closer. If Alpha Centauri embodies romance and hope, then Barnard's star stands as a symbol of time itself, of the universe's constant motion. It reminds us that nothing in the cosmos is permanent, not even stars. They drift, they shift, and over ages they redraw the sky's very map. And beyond Barnard's star, the journey takes us to stranger places still. Some stars are so faint they barely register, ghost-like presences that only the keenest telescopes can spot. One of them is Wolf 359, invisible to the eye, yet immortalized by one of the most famous battles in Star Trek lore. And that's where our adventure continues. If Barnard's star is like a tireless old man rushing toward us at record speed, then Wolf 359 is its complete opposite. This is a star almost no one has heard of, and even stargazers struggle to find it. To the naked eye, Wolf 359 is practically invisible, so faint it only shows itself through sensitive telescopes. And yet, it's one of the sun's closest neighbors, just about 8 light years away, quietly residing in our cosmic backyard. Wolf 359 is a red dwarf, and not just any red dwarf, but one of the faintest stars ever discovered. Its brightness is only 1/60% of the sun's. If you swapped it with the sun, Earth would be plunged into a frozen darkness, lit only by a weak red glow, a dim twilight that could never sustain life. Its mass is just a tenth of the sun's, making it feel less like a star and more like a dying ember adrift in the infinite sea of space. What makes Wolf 359 so unusual is its calm. Unlike Proxima Centauri, which erupts with violent flares, Wolf 359 seems to have chosen a different path. It doesn't thrash with storms or lash out with deadly radiation. Instead, it burns quietly, consuming fuel so slowly that on the cosmic timescale, it's practically immortal. Astronomers estimate that stars like Wolf 359 can survive not just billions, but trillions of years. For comparison, our sun will run out of fuel in about 5 billion years. By then, Wolf 359 will still be glowing faintly, long after the sun has died. Earth has vanished, and humanity, if it survives, has wandered to the galaxy's edge. In that silence lies a strange beauty. Wolf 359 is like a stubborn flame that refuses to die, a small but steady spark defying the flow of time. Surrounded by darkness, it gives off only a faint red light, but that light will endure, bearing witness to the rise and fall of civilizations, a quiet observer of cosmic history. So far, no planets have been found orbiting Wolf 359. The search continues because discovering one would be revolutionary. A stable star that burns for trillions of years with a planet in its habitable zone, shielded from deadly radiation and holding a steady orbit, could be the ultimate cradle of evolution. But for now, it remains only speculation. Wolf 359 keeps its secrets, like a reclusive neighbor who reveals nothing. Despite being so dim in astronomy, Wolf 359 found an unexpected spotlight in popular culture, thanks to the legendary series Star Trek. In that universe, the Battle of Wolf 359 is one of the most iconic events, where the Federation faced the Borg in a catastrophic clash. Ever since, the name Wolf 359 has been tied to destruction, fear, and resilience, etched into the minds of millions of fans. It's fascinating that a star nearly invisible in real life became a symbol in human imagination, proof that sometimes science and culture intertwine to turn the unseen into legend. If you pointed a telescope at Wolf 359, all you'd see is a tiny red dot, unremarkable at first glance. But behind that dot lies a story of endurance, of a faint ember burning longer than galaxies themselves. It reminds us that not every star needs to shine brightly to matter. Some remain quiet, steady, nearly eternal, and yet still become icons, at least in the human mind. That's why Wolf 359 makes such a perfect counterpoint to Barnard's star, the restless runner, and Alpha Centauri, the dazzling duo. Each star in our neighborhood has its own personality. If Alpha Centauri is the light of hope and Barnard's star the embodiment of motion, then Wolf 359 is the symbol of stillness and endurance. It's like a deep red ghost drifting through billions of years, silent but never fading. But right after this silence, our journey takes a dazzling turn. Leaving Wolf 359 behind, we arrive at a star that's its complete opposite, the brightest in the night sky, blazing so brilliantly that anyone can see it with the naked eye. This is Sirius, the dog star, a timeless beacon in human history. And there, we leave the shadows behind and step into the brightest light the heavens have to offer. As we drift away from the dim shadow of Wolf 359, our eyes are suddenly struck by a dazzling brilliance, almost blinding in its intensity. Across the night sky, among countless twinkling stars, one stands out, so bright, so unmistakable that it commands our attention. This is Sirius, the dog star, the brightest star visible to the naked eye from Earth. With its radiant blue-white glow, Sirius has long been a beacon of wonder, a celestial landmark, and a symbol woven into human culture for thousands of years. At first glance, Sirius looks like nothing more than a single brilliant point of light. But when science peeled back the veil, we discovered that Sirius is not alone. It is a binary system, two stars bound in a complex celestial dance. Sirius A, the primary star, is a young blue-white giant, twice the mass of the sun and 25 times brighter. It blazes with raw energy, ruling the sky with its brilliance. Its companion, Sirius B, tells a very different story. A white dwarf, the remnant of a once shining star, now reduced to a hot, dense core. Remarkably, Sirius B was the very first white dwarf ever discovered, opening the door to our understanding of stellar life cycles. This contrast paints a striking picture. One star in the fiery bloom of youth, the other in the quiet weight of old age. Sirius A shines with vigor and radiance, while Sirius B, no larger than Earth, yet hundreds of thousands of times denser, reminds us of impermanence. One embodies vitality, the other inevitability. Together, they form a cosmic symbol of the cycle of life and death among the stars. From the dawn of civilization, Sirius has played a vital role in human history and belief. To the ancient Egyptians, it was sacred. They noticed that when Sirius reappeared in the pre-dawn sky after its absence, the Nile floods would soon follow, bringing rich silt and the promise of life to their land. For them, Sirius was the star of rebirth, a harbinger of prosperity, and it was closely linked to the goddess Isis, deity of love, life, and magic. To the Egyptians, Sirius was more than a star. It was the heartbeat of their civilization. In ancient Greece, Sirius was called Sirios, meaning scorching or glowing. They placed it in the constellation Canis Major, the Great Dog, which gave rise to its nickname, the Dog Star. Later, the Romans carried this idea forward, coining the phrase, the dog days of summer, to describe the hottest days of the year, when Sirius rose with the sun. To them, Sirius marked both oppressive heat and the abundance of harvest, a reminder that fire could both nurture and challenge life. Yet Egypt and Greece were not alone in their reverence. Across cultures, Sirius has inspired stories and meaning. Ancient Chinese astronomers named it the celestial dog star, an omen of great changes. Polynesian navigators used it as a guiding light across the vast Pacific. To many civilizations, Sirius was both mythic symbol and practical tool, a cosmic compass across space and time. Even today, Sirius retains its special place in science. As the brightest star in the night sky, it serves as a benchmark, a standard of comparison for measuring the apparent brightness of other stars. Astronomers often calibrate their observations against it, and its strong, steady light has even been used to fine-tune modern telescopes. Sirius remains both an object of study and a foundation stone in astronomy. So when you lift your eyes on a clear night and see Sirius shimmering in blue-white light, remember, it's more than starlight. It's light that has traveled 8.6 years across space to meet your gaze. Light that carries with it thousands of years of cultural meaning, ancient myths, and precise scientific measurement. Light born of a stellar duet, youth blazing with vitality beside an elder burning quietly, together telling the story of time itself. For us, Sirius feels like a crescendo. After the silent gloom of Wolf 359, its brilliance bursts forth like a festival in the heavens. But our journey does not end here, because just beyond that blinding glow lies a star far quieter, far more reserved, yet it shelters a small, calm planet, one that may be among the most promising candidates for life beyond Earth. That star is Ross 128, and our voyage continues there. After leaving behind the dazzling, almost blinding light of Sirius, our journey brings us to a far humbler star, smaller and quieter, yet carrying within it a tremendous sense of hope. This is Ross 128, a red dwarf star about 11 light-years away from Earth. In this crowded cosmic neighborhood, Ross 128 is like the quiet neighbor who never bothers anyone, but somehow captures the attention and high hopes of the entire scientific community. Like most nearby stars, Ross 128 is a red dwarf. That means it's small, faint, and destined to live far longer than big stars like our Sun. But unlike other red dwarfs we've encountered, like the famously volatile Proxima Centauri, Ross 128 is astonishingly calm. While Proxima is known for unleashing violent flares, showering its planets with ultraviolet and X-ray radiation, Ross 128 rarely does anything of the sort. It's more like a small oil lamp, burning steadily and gently, never erupting without warning to scorch everything around it. This quiet temperament is one of the main reasons astronomers are so fascinated by it. In 2017, a discovery catapulted Ross 128 from an unremarkable faint star to the center of scientific attention. Astronomers found a planet orbiting it, Ross 128b, nearly Earth-sized, just slightly bigger and heavier, but sitting right in the star's habitable zone, where temperatures could allow liquid water to exist. And liquid water, as far as we know, is the essential ingredient for life. Even better, because Ross 128 is a peaceful star. Its planet isn't constantly blasted by deadly radiation storms like Proxima b is. That makes Ross 128b one of the most promising candidates yet in the search for alien life. Scientists believe that if a planet can hold onto its atmosphere for billions of years, if it has water, and if its star is gentle enough not to destroy everything, then it could very well be a place like Ross 128b. Picture it. Under the soft red glow of Ross 128's sky, there might be a world with mild climates, rippling oceans, and sprawling continents. Its atmosphere, if it has one, could be tinted in strange colors, reflecting the star's signature crimson light. And somewhere, in the water or beneath the rocky soil, simple forms of life might already exist, or may once have existed. At just 11 light-years away, Ross 128b is close enough for us to dream about sending spacecraft one day, or at least studying it in detail with the telescopes of the future. There's another curious fact. Ross 128b orbits its star in just 9.9 days. In other words, a year on this planet is shorter than 10 Earth days. If you lived there, you'd be celebrating New Year's practically every week. But because it's so close to its star, Ross 128b may be tidally locked, always showing the same face to Ross 128, just like our moon always shows one side to Earth. If that's the case, one half of the planet would be locked in eternal night, while the other basks endlessly in the red glow. Yet in between, along the twilight strip between light and darkness, conditions might be just right for life. This possibility keeps astronomers endlessly intrigued. Ross 128 isn't just a scientific curiosity, it's a beacon of hope. It offers a gentler counterpoint to the harshness of Proxima Centauri. If Proxima b represents the tragic fate of a planet tormented by radiation, Ross 128b suggests the vision of a calmer world, where life has a real chance to endure. It reminds us that the universe isn't entirely hostile, that not every planet is doomed from the start. Somewhere out there, nature can be kind, and Ross 128b might be proof of that. That's why Ross 128b is a prime target for next-generation telescopes like the James Space Telescope. By studying the light passing through its atmosphere, scientists hope to find signs of oxygen, methane, or even elusive biosignatures, chemical fingerprints that might hint at life. Just a single clue, one faint signal, could shake science to its core and forever change how we see our place in the cosmos. But Ross 128 doesn't stand alone. As compelling as it is, it's just one member of a vast stellar neighborhood around Earth. Within 16 light years, there are dozens of other star systems, each with its own story, its own mysteries. To truly grasp the bigger picture, we can't stop at Ross 128. This neighborhood is full of characters. Binary stars, once used to measure distance, young stars with giant planets, systems hosting multiple super-Earths. So after pausing at Ross 128, our journey will continue, leaving behind this hopeful world as we dive deeper into the richness of the stellar neighborhood, where 50 star systems coexist in a lively, diverse tapestry, reminding us that Earth is just a very small piece of an infinite universe. If we think of the universe as a vast city, then the space around our sun is our little neighborhood, a small corner of the cosmos that turns out to be far more crowded than the naked eye suggests. Within just 16 light years, a distance that seems tiny on a cosmic scale, there are about 50 star systems, home to some 65 stars and a handful of quiet brown dwarfs. Together, they make up a diverse community of neighbors, each with its own personality, from dazzling points of light visible to the eye to faint, elusive companions that only reveal themselves through telescopes. What's striking is that most of these stars look nothing like the sun. In fact, the majority are red dwarfs, smaller, cooler, and dimmer than our star. They don't dominate the skies, but they make up about 70% of all stars in the galaxy. In other words, our neighborhood mirrors the larger reality of the Milky Way. The universe isn't brimming with bright, blazing suns, but with countless little lanterns glowing softly in the dark. That makes them harder to study, yet it also hints at the possibility that many of them may host hidden, promising planets quietly circling, waiting to be discovered. Among these nearby stars, a few stand out enough to have earned names on humanity's cosmic map. Take Lalande 21185, for instance, a red dwarf just 8.3 light-years away. Invisible to the naked eye, it has nonetheless become a star of interest because data suggest that up to 2 super-Earths may orbit it. If they exist, these worlds would be larger and rockier than Earth, and in the best-case scenario, one of them could sit in the habitable zone. They're like new houses springing up in the neighborhood, instantly drawing attention and curiosity. Another memorable neighbor is 61 Cygni, a double star system about 11.4 light-years away. Its pair of orange stars are smaller and dimmer than the sun, but they occupy a special place in the history of science. In the early 19th century, 61 Cygni became the very first star whose distance was successfully measured by parallax, showing once and for all that stars aren't unreachable specks, but real suns at measurable distances. That breakthrough opened a new chapter in astronomy and earned 61 Cygni the nickname the Flying Star, both for its swift proper motion and for its historic role. Our neighborhood also hosts younger, more dynamic stars. Epsilon Eridani, just 10.5 light-years away, is one of them. Smaller and younger than the Sun, it comes with its own giant planet, Epsilon Eridani, along with a dusty debris belt, a setup that resembles a younger version of our solar system. Because of this similarity, Epsilon Eridani has long captured imaginations in science fiction, appearing in stories like Star Trek as a possible second home for humanity. It's like the freshly built house down the block, full of promise, making everyone curious to peek inside. Then there's GJ 1061, only about 12 light-years away. It's a tiny red dwarf, but it boasts 3 known planets, at least one of which sits in the habitable zone, where liquid water could exist. The star's calm nature, combined with the planet's promising orbit, makes this system one of the top contenders on the list of humanity's dream destinations in the search for life. It reminds us that in our cosmic neighborhood, not every house is dark and cold. Some may hold a warm light, quietly waiting to be found. What makes this stellar neighborhood so fascinating is its variety. There are close-knit binaries like 61 Cygni, youthful stars like Epsilon Eridani, still carrying the marks of planetary formation, quiet red dwarfs like Ross 128, and restless stars like Proxima. This richness turns our local space into a living laboratory, offering scientists a front-row seat to almost every scenario the universe can create, from icy planets to desert worlds, from ancient stars to newborn suns. Seen from this perspective, the sun doesn't look so lonely after all. It's just one member of this larger community, one lamp among dozens, each shining in its own way. Realizing how crowded our neighborhood truly is has reshaped our view of the cosmos. If there are 50 star systems within just 16 light years, then what about the entire Milky Way with its 100 billion stars? And if even in this small corner we find worlds that could harbor life, then the odds of life existing somewhere else in the galaxy become very hard to dismiss. Our stellar neighborhood is a mirror reflecting our place in the universe. Earth, with all its abundance of life, is not an isolated island, but one home among many in a vast community, with neighbors who may be faint, quiet, or hidden, but always there. To better understand ourselves, we must also learn to observe, to listen, and to explore those neighbors. And yet, the story doesn't end here. Because once we step beyond this 16 light-year boundary, we encounter a name that once shook the world, a star system once hailed as the home of a second Earth, only to become the center of heated debate. That system is Gliese 581, and our journey is about to enter a far more dramatic chapter. If the neighborhood of stars within 16 light-years of Earth feels like a calm and modestly diverse community, then just beyond its edge, around 20 light-years away, lies a star that once ignited both scientific excitement and public imagination, only to later sink into years of debate. That star is Gliese 581, a faint red dwarf in the constellation Libra, once hailed as the home of a second Earth. In many ways, Gliese 581 isn't all that remarkable compared to other nearby stars. It's small, cooler, and shines far more dimly than the sun. Standing on a planet orbiting it, the sky wouldn't blaze with white light, but instead glow with a soft crimson, bright enough to illuminate, yet gentle rather than harsh. But what made Gliese 581 famous wasn't the star itself. It was the planets discovered around it. In the mid-2000s, astronomers confirmed that Gliese 581 hosted at least 4 planets. Among them, Gliese 581c and Gliese 581d were considered possible homes for life. Both are larger than Earth, classified as super-Earths, and orbit near the edges of the habitable zone. Scientists debated whether their surfaces might hold liquid water, and whether their atmospheres, if they had any, could trap heat just enough to make them livable, or instead push them into a runaway greenhouse state like Venus. Even with all those unknowns, just the possibility of such candidates was enough to turn Gliese 581 into a hotbed of exoplanet research. The peak of excitement came in 2010 when a research team announced the discovery of Gliese 581g, a planet roughly Earth-sized, sitting in just the right spot within the habitable zone. The news exploded across global media. Second Earth became a headline everywhere, conjuring visions of a world humanity might one day set foot on. Gliese 581g became a symbol of the hope to find life beyond Earth, of the dream that we are not alone in the cosmos. But the joy didn't last. Just a few years later, other teams reported that the supposed signals of Gliese 581g might actually have been noise in the data, caused by activity on the star itself. A planet once seen as so promising turned out to be a mirage. Its very existence was called into question, and to this day, Gliese 581g remains one of the most debated cases in exoplanet science. The dream of a second Earth dissolved almost as quickly as it had appeared, leaving behind a sobering lesson. Confirming a planet in the universe is far harder than it seems. This reality highlights the difficulty of searching for other worlds. The methods we use, from detecting a star's tiny wobbles as a planet tugs on it, to watching its light dim when a planet crosses in front, are exquisitely sensitive, but also prone to interference. A small irregularity in the data can create the illusion of a planet that isn't really there. Gliese 581g came to embody both hope and caution, reminding us that in science, wonder must always walk hand in hand with rigorous verification. And yet, whether or not Gliese 581g is real, the system still matters. It still has at least 4 confirmed planets, with Gliese 581c and Gliese 581d continuing to draw attention. With just slight differences in atmosphere or surface conditions, either could edge closer to being habitable. That's why astronomers keep watching Gliese 581, treating it as a natural laboratory for understanding the diversity of planets across the universe. Gliese 581 also carries a unique mark in humanity's story of reaching outward. In 2008, Earth sent a special radio transmission called A Message from Earth to this star system. It carried greetings, pictures, and words from tens of thousands of people around the globe, like a cosmic letter to distant neighbors. The signal will take about 20 years to arrive, and perhaps it will never be answered. But the act itself speaks volumes about humanity's desire to reach beyond, in the hope that someone, somewhere, might be listening. So Gliese 581 is more than just a distant red dwarf. It is a mirror reflecting both humanity's dreams and disappointments. It shows us how fragile hope can be when built on uncertain data, yet also how powerful the urge to explore remains. For even after setbacks, we keep searching, we keep dreaming. And if one day we truly do find another Earth, perhaps the debates over Gliese 581 will be remembered as a necessary stumble along the difficult road toward discovery. Leaving Gliese 581 behind also marks the moment our journey takes us beyond the stellar neighborhood. We've already passed familiar and contested names: our Sun, Proxima, Alpha Centauri, Barnard's Star, Sirius, and Ross 128. Now, crossing beyond 20 light-years, we've only just reached the edge of the front yard in a Milky Way that stretches 100,000 light-years across. It's a reminder that what we've seen so far is just the beginning, with an entire vast universe still waiting to be explored. When we look back at the journey we've just taken, perhaps the most striking thing isn't any single star, but the overwhelming sense of the universe's vastness. From the blazing sun, the birthplace of all life on Earth, to the restless Proxima Centauri, from Alpha Centauri, the familiar pair woven into our culture, to the aging and hurried Barnard's Star, from the dying ember of Wolf 359 to the fierce brilliance of Sirius, from the gentle Ross 128 to the controversial Gliese 581. Together, they paint a vivid portrait of our stellar neighborhood. And yet, after all this, we've only traveled a mere 20 light-years, a distance so small it's almost laughable compared to the Milky Way's sprawling 100,000 light-years. It's like stepping just a few paces beyond your front door while an entire city still lies ahead. But those first steps matter because they remind us that stars aren't just cold specks of light scattered across the night sky. They are destinations, hidden worlds, invitations echoing from the depths of the dark. Each star could be a story, a mystery, a test of our curiosity and courage. The stellar neighborhood is only the beginning, but it's enough to awaken the feeling that we are not alone. Earth isn't some lonely island adrift in space, but a home nestled in a bustling community, surrounded by dozens, even hundreds of silent neighbors. And if within this tiny patch we've already found promising worlds like Proxima b or Ross 128b, then how many more might be waiting beyond, in places where starlight has yet to reach our eyes? Perhaps the most important gift of this journey is the shift in perspective, both on the universe and on ourselves. We are small, fragile, nothing more than a mote of dust in an ocean of stars. But it is that very smallness that fuels our desire to reach farther. For thousands of years, humans have looked up at the sky and wondered, is anyone out there? And now, with giant telescopes and daring space missions, we are inching closer to an answer. This 20 light-year journey, in the end, is just a prologue. The real adventure is only beginning, one that won't stop at our stellar neighborhood, but will stretch to the edges of the Milky Way and perhaps beyond. It is a story not only of science, but of dreams, of the longing to explore that runs deep in the veins of our species. And as we keep moving forward, every star, every planet, every faint signal from the cosmos will become a new chapter in that endless epic.